Welcome, welcome. This one is the road. Bicycle, van, no one is here. मंगल भवन मंगलहारी. शंकर. Wow, 31, 31, 20 viewers are seen. Hi, Suman Saha. Hi.
What is carbon and its compound? Carbon is an element. The symbol of carbon is capital C. It is a non-metal. The name carbon is derived from the Latin word carbo, which means coal. This is because the carbon is the main constituent of coal. The amount of carbon present in earth crust atmosphere is very small. For example, the earth crust contains only 0.02% of carbon in the form of minerals. like carbonates, like coal, like petroleums, etc. And the atmosphere has only 0.03% of the carbon dioxide gas. In spite of this small amount of carbon available in nature, the carbon element has an immense importance in every. The importance of the carbon can be gauged from the fact that we are ourselves made of carbon compounds called organic compounds. In fact, all the living things, all the plants, all the animals are made up of carbon based compounds which are called organic compounds. Thus, carbon element is present in all living things. A large number of things which we use in our daily life are made up of carbon compounds. Our food material like grain, pulses, sugar, tea, coffee, fruits and vegetables etc. are the carbon compounds. The material like cotton, silk, wool, nylon and polyester which are used for making clothes are carbon compounds. The fuel like wood, coal, kerosene, natural gas, petrol, diesels, which we use for the cooking foods and vehicle running, these are the carbon compounds. The paper, plastic, rubber, leather, drugs, dyes are also made up of carbon compounds. It is clear we can test the presence of carbon in a material on the basis of the fact that the carbon and its compound burn in air to give the carbon dioxide gas, which turns lime water milky. This test can be performed as follows. Consider burn the given material in air. Pass the gas formed through lime water. If the lime water turns milky, we say the given material contains carbon. Carbon has its nature that it always forms covalent bonds. The atomic number of carbon is 6, which means that neutral atom of carbon contains 6 electrons. So the electronic configuration of carbon is 2 4. It is clear that carbon has 4 electrons in its atomic number. What happened? It should either lose 4 electrons or it should gain 4 electrons to the inert gas electronic configuration and become stable. Now the carbon atom is very small, due to which its outermost electrons are strongly held by the nucleus. So it is not possible to remove the 4 electron from the carbon atom to give it the inert gas configuration arrangement. It is also not possible to add the 4 electron to a carbon atom due to some energy considerations and acquire the inert gas configuration. It is obvious that carbon atoms have to acquire the inert gas structure of the 8 electron in its outermost shell by sharing the electron. Since the carbon atom can achieve the inert gas electronic configuration only by sharing of the electrons, therefore the carbon forms covalent bond. The carbon forms always covalent bond by the sharing of the electrons. Carbon is tetravalent. A carbon atom has 4 electrons in its outermost shell. So it requires 4 more electrons to achieve the stable configuration of the 8 electron in its outermost shell, which it gets by sharing. Since one carbon atom requires 4 electrons to achieve the 8 electron inert gas configuration, therefore the valency of carbon is 4. That is, carbon is tetravalent. Tetra means 4, valent means valency. So the 4 valencies of the carbon are usually represented by putting 4 short lines around the symbol of the carbon. The most outstanding unique property of the carbon is its ability to combine with itself, atom to atom, to form the long chains. For example, let us consider the case of the octane. Octane is C8H18, a group of alkane group, one of the constituent of the petrol. Also, it has a chain of 8 carbon atoms, and some of the organic compounds like starch and the cellulose contain chain of 4 carbon atoms. This property of the self combination of the carbon atom to form long chains is useful to us because it gives rise to an extremely large number of carbon compounds, organic compounds. This is because a very long chain of the carbon compounds act as a backbone to which other atoms can attach in a number of ways to form a very large number of the carbon compounds. The covalent bond between various compounds of the carbon atom are very strong and do not break easily. The reason for formation of a strong bond by the carbon atoms is their small size. Due to the small size of the carbon atom, their nuclei hold shared pair of electrons between atoms strongly, leading to the formation of a strong carbon atom also form a strong covalent bond with the atom of the other element such as hydrogen, oxygen, nitrogen, sulfur, chlorine and many other elements. The formation of a strong bond by the carbon atoms among themselves and with the other elements makes the carbon compound exceptionally stable.